All right, you are welcome to today's class with your teacher and Christopher GK, your chemistry teacher. All right, let's begin with this particular picture. Let's begin and look at plastic materials, motor oil, diesel, gasoline, and trees or even forests, and look at them critically and analyze what is common in these things. When you look at plastic, you observe that the component of it is made up of hydrocarbons. If you look at motor oil, the components are hydro and carbon, hydrogen and carbon compounds. If you look at diesel and even gasoline, hydrogen and carbon compounds. And in trees or forests, as the case may be, there is a component in tree that is called carotene, the pigment. Inside the pigment of that particular tree, we have carotene on it. And the carotene, the component inside also, is made up of hydrocarbons, that is hydrogen and carbon compounds. So these things are common in these substances. The hydrogen and carbon are common in these particular substances or objects. For that reason, we will be looking at this particular hydrocarbons to see what they are and their sources, what they do, or what is unique about it. So our topic for today is hydrocarbons. Our topic is hydrocarbons, and it's expected that by the end of this particular class, you should be able to explain the meaning of hydrocarbons and at least give 5 examples. Then you should also be able to classify hydrocarbons. That means classification of hydrocarbons. Another thing, you should also define homologous series. Know what homologous series is and define it with even examples of homologous series. Then lastly, you also been able to learn in this particular video or class the characteristics of homologous series. We will take them one after the other and run down the class. 1. What is hydrocarbon? Hydrocarbon. Hydrocarbons are organic compounds that compose of carbon and hydrogen only. When an organic compound is composed of hydrogen and carbon only, we call it hydrocarbon compound. That means hydrogen and carbon joined together, we call it hydrocarbons. They occur naturally in natural gas, coal, and petroleum, which is crude oil. Hydrocarbons are the principal constituent of petroleum and natural gas. They serve as fuel and lubricants, as well as the raw materials for production of plastic, fibers, rubbers, solvents, explosive, and industrial chemicals. These particular hydrocarbons occur, as I said before, in nature. In addition to making up fossil fuels, they are present in trees and plants. I said it before when we began. For example, the pigment that we call carotene, we find them in carrots and in green leaves. The hydrocarbons are found there naturally inside the carotene of a green leaf or a plant. These are the places where we can find them hydrogen and carbon compound found naturally in these places. Now let's classify them. Hydrocarbons can be basically classified into 2. Hydrocarbons are classified basically into 2. They are aliphatic hydrocarbons and aromatic hydrocarbons. Why hydrocarbon? I said that it's classified into aliphatic hydrocarbons and the aromatic hydrocarbons. Now, aliphatic hydrocarbons can further be divided or classified into saturated hydrocarbon and the unsaturated hydrocarbons. Saturated hydrocarbons are their kings. a family called alkanes. Now, unsaturated hydrocarbons are alkenes and alkynes. Now, we are going to further look at it to know why are they saturated while the other one is unsaturated. Now, saturated hydrocarbons are single bonds. Unsaturated are the double or triple bonds. Then the alkanes have only single bond, as I said. That means saturated hydrocarbon. While the unsaturated are the alkenes and the alkynes. Alkenes and the alkynes. Alkenes have two double bonds, while the alkynes have triple bonds. Triple bonds, alkynes. Now, hydrocarbons. Now let's talk more into issue of aliphatic hydrocarbon and the aromatic hydrocarbons. Aliphatic hydrocarbons are those in which carbon atom form either straight chain or branch chain. We call them alicyclic. Alicyclic means they are not cyclic, they are not ring. Or they can also exist as ring, which is we call it cyclic. Aliphatic hydrocarbons are those in which the carbon atoms form either straight chain or branch chain, while the saturated hydrocarbons are single bonded, unsaturated are double or triple bonded. So between carbon and carbon bond, they are single bond. That is saturated hydrocarbons. Now, unsaturated hydrocarbons have multiple or triple bonds exist between them. It could be double bond, it could be triple bond. Double bond, we call it alkenes. Triple bond, we call it alkynes. So saturated are the alkenes, while unsaturated are the alkenes and alkynes. While now the aromatic are cyclic, highly unsaturated. They are the benzene and its derivatives. So benzene is the most common aromatic hydrocarbon. Benzene and its derivative. That means every other aromatic hydrocarbon must be benzene structure, then and other things being added to it, something like naphthalene and anthracene. We also have something like phenol, toluene, and other nitrobenzene, and the amine, benzenamine, and others. But they must have to be from benzene structure, first of all, and other ones. Now, what is homologous series? It's just like asking someone, what is your surname? The way we have family name, we do regard it as surname. So we have homologous series in chemistry as the names, family names of organic compounds. Homologous series is a family of organic compounds which follows a regular structural pattern in which each successive member differ in molecular formula by CH2 group or by molecular weight of 14 units. Now, they are families, but they follow a regular structural pattern in the sense that if group number one is so formula, it will be different from the another one by CH2. Or if you calculate the relative molecular mass of it, it will be differ by each other by 14. Now, that is what we mean. It's a family. Each one has a family, just the way we call alkene. Alkene is a family. Alkene is also a family. Alkyne is a family. Alkanoid is a family. Alkanoic is a family. Alkanoate is a family, and all of that. And they follow a structural formula in order for you to generate their membership. That is what we mean by homologous series. It's a family of organic compound. Now, alkanes, the formula to use, general formula for all the members of alkene, the general formula is CnH2n plus 2. With this formula, you will get the members of alkanes to any number you want. The first carbon atom, you put N as 1. Then second carbon atom, you put N as 2. Then alkene, you have Cn2H2n. With that, we have alkyne CnH2n minus 2. And so on. With that, you generate other members, both for alkanol and all of that. They have their homologous series, which we are going to talk about later. so and so on. Now let's take example of that of the alkane that I just mentioned now with their general formula. The general formula for alkanes is CnH2n plus 2. With that, first carbon atom, when you put one in N there, put anywhere, multiply through, you're going to have CH4. And the name of that compound is methane. Second one is ethane. Third one is propane. Fourth one is butane. Fifth, pentane. Sixth, hexane. Seventh, heptane. Eighth, octane. 9, nonane, and 10, decane. And with that formula, you generate all these formulas. With that particular general formula, chemical formula, you generate their molecular formula of these members. That is how you can use for other families or homologous series based on their general formula for all their membership. Now, all the members belonging to a series, belonging to a particular family, have the same functional group. Like the alkane, now we know that they have single bond. So all the alkane family must have single bond. That family or the homologous have similar physical properties that follow a fixed gradation with increasing mass. They have the similar physical properties. Chemical properties of the members of the homologous series are the same due to the fact that they have the same functional group. They have the same functional group, so their chemical properties are the same. All right, let's take a look at some homologous series. We have a series called alkane, single bond. We have alkenes, we have alkynes, we have haloalkanes from alkane. We have alcohol, which is alkanol family. We have ester, which is alkanoate family. We have aldehydes. We have another family, ketone. We have carboxylic acid. We have ester. We have amide. We have nitroalkane. We have amine. These are several. We have so much many families of organic compounds in chemistry. But this is what we mean by a homologous series, family name. And you can see their general formula, which you can use to generate their members. Then, even in their pronunciation, they have unique way of pronouncing them. Like their kings, their name must end with, as a suffix, end with ane. Alkane, methane, propane, ethane, butane, heptane, and all of that. Alkanol, their prefix should be ol, ol. So that is what we mean by that. Ether is alkoxy, aldehyde is nal, that means alkanal. Ketone is known, which is alkanone, under alkanone. Carboxylic has to do with alkanoic acid. It must end, suffix must end with noic, oic acid. Amine, which has to be either prefix as amino or suffix as amine. It depends. So that is what we mean. So each family have their name. The way surnames differ in our normal name as a human being, their names also differs by their pronunciation, either as with suffix or the prefix, what starts it or what ends it. These are what we mean by homologous series. We can see an example. That of the alkane, we have ethane. That of the alkenes, we have 18. You see ENE. That of the haloalkane, we have chloroethane. That of the alkanol, we have ethanol, and all of that. That same aldehyde, we have ethanol. Ketone, we have propanone. Carboxylic, we have ethanoic acid. That for the same. That is the uniqueness. And we say they have the similar chemical properties because they have the same functional group. We can see their functional group, what makes them similar. Alkane, they are all single bond, alkene, double bond, and all of that. All right, let's move to their characteristics. Homologous series, all members of the series share a general molecular formula. I said it before. Alkane, we know the alkane's own is CN H2N plus 2. For alkanes, we have CnH2N for alkene, and so on. All of them. So any particular family must have general molecular formula to generate it. Number 2 thing that is one of the characteristics of homologous series is that the successive member differ in molecular formula by CH2. In the membership of a particular family or homologous series, the difference between number 1 and number 2 is CH2, or when you calculate their molecular mass, the weight, it will differ by 14. That means carbon 12 plus 2 of hydrogen gives you 14. That is one of the characteristics. And that is the chemical properties of the members are similar, but with gradual variation along the series. They are similar, but we know that as the number of carbon atoms increases, there will be little variation in the process. Now, number 4 is that the physical properties like melting point, boiling point, density, solubility, they will change gradually as the number of the carbon atom per molecule increases. So this variation may be from gases, being gaseous, to liquid form, to solid, small as it increases in number, just like the alkane family. Then number 5 is that all members can be prepared by the same general method. You can prepare them. If this one uses this particular method of preparing it, the second one should also be prepared like that. It's just a matter of changing the number of carbon atoms based on what you want to prepare. So they can be prepared in the same way. That is this. What have we done so far? We said that hydrocarbons are organic compounds that are composed of carbon and hydrogen only. Then hydrocarbon, we also say that they are principal constituents of petroleum and the natural gas. This is what we have done, and some other classification we have done. Now, all right, we are going to take this one as an assignment. WAEC 2012 number 1 says briefly explain briefly the term homologous series using an appropriate example. We have done what homologous series. Explain it. What do you understand by that? Then give an example. Any homologous series you want to use. Then number 2, we said give 3 characteristics of homologous series. That is why question 2015 number 3. Then name 2 groups of compound which form such kind of series. Give 3 characteristics of homologous series. Then give 2 groups of compounds which form such a series. I think we have done all these things, and make it a trial. And for further study and inquiry, you can consult to Essential Chemistry, Understanding Chemistry, New School Chemistry, compile past question and answers. Then you can contact me through my WhatsApp line 080-655-73229, or email me at acristo116@gmail.com. And this is where we'll end it for today. Thank you for